Algebra 2, we are doing page 204. We're going to do 1 through 26. This will be a 2-day assignment, and then we'll do one more assignment for Thursday and Friday. So I'm going to be doing the odds right now. The calculator will come in handy, especially if it's the Casio. It'll make it a lot easier today. So number 1, we're supposed to be... Start. Wake up. Here's the magic button. Lovely. All right, number 1, square root of 54. Okay, we're not plugging this in our calculator as a decimal. We need to simplify it, and we've done a little bit of this already, so hopefully you guys remember. If you use the factor tree, the prime factors will help us get it. So 54 is 2 times 27, and 27 is 3 times 9. And 9 is 3 times 2. So what we did, I don't know if you guys recall, but we took the doubles and put those in front, and the leftovers we put in back. So a double 3 goes in front as a 3, and in the square root we got 2 and 3 left over, and 2 and 3, 2 times 3 is 6, so it's 3 square root of 6. Would be the answer for that one. That's how it goes. All right, number 3 says 2 square root of 147. Okay, I'm just going to ignore that 2 for now and bring it back later on. So 47, if you plug in your calculator, like divide by 3, you will get 3 times 49. Okay, you just gotta play around with it, see what goes into it. 49, if you guys remember, is 7 times 7. Okay, that means, those are primes. 7 is gonna go on the outside, 3 on the inside. Now, there was already a 2 in front of it, so really what's happening is we got a 2 on the outside and a 7 on the outside, and 3 is on the inside. So 2 times 7 go together to make 14. So this would be 14 square root of 3 for number 3. Okay, number 5. Square root of negative 4. Okay, this is something new. When you have the square root of a negative, like for example, square root of negative 1, what times itself equals negative 1? That's what this means. What times itself equals negative 1? Well, 1 times 1 is 1. Negative 1 times negative 1 is 1. So this doesn't really make much sense. Nothing times itself equals negative 1. So what they did was they said, well, this is an imaginary number. So they just called it square root of negative 1. They just called it I for imaginary. Evidently, this has some kind of application. I don't know what it is, but we gotta learn it anyway. So I is the square root of negative 1. Now back to number 5. The square root of negative 4, that doesn't work either. 2 times 2 is 4, negative 2 times negative 2 is 4. There is no square root of a negative 4. So what we do is we break it apart into 2 different things. Square root of negative 4 is like the square root of negative 1 times the square root of 4. So you can like kind of take that negative out. The square root of negative 1 we just call I. And the square root of 4, what times what equals 4 is 2. So we call this answer 2i. It's an imaginary number. So really, we didn't really do much different than square root of 4. So square root of 4 is 2, square root of negative 4 is just 2i. So anytime you have a negative inside the square root, it's going to come out as an I in summation. Okay, that's number 5. Number 7. Shoot. Okay. On number 7, kind of the same thing. Ignore this negative for a second. Square root of negative 25, that's imaginary. It's not a real number. So the negative inside the square root becomes an I. The square root of 25 is 5. So this is just 5i, but there's a negative sticking out in front. So it just becomes negative 5i. So the negative in the square root, only thing it does is add an I on. Alright, I was just looking at a couple of evens. I probably shouldn't. Whoa. Okay, whoops. Earlier when I said number 3, that was actually number 2. So I skipped number 3. So I'm going to go back and do number 3. Okay. Number 3, can square root of 6 simplify? There's no doubles in 6, so no, it doesn't simplify. Here's the problem though. You're not supposed to leave a square root in the denominator. That's a no-no. So the way you fix it is when you multiply a square root times itself, it gets rid of the square root. Whatever you multiply to the bottom of the fraction, you're supposed to multiply the top of the fraction to keep the value the same. So you multiply the top by square root of 6. So the top becomes 1 times square root of 6. 1 times anything is just itself. The bottom becomes square root of 6 times square root of 6, which is square root of 36. And square root of 36 is normal 6. When you take a square root times itself, it always just becomes a normal number. Square root of 6 times square root of 6 is just going to be 6. Square root of 7 times square root of 7 is 7. And so on. Alright. These do not reduce. Square root of 6 over 6. You can't divide square roots with normal numbers. You can't multiply square roots with normal numbers. They don't simplify. They don't make a nice, neat answer. So we just leave them separate. Okay, you could plug it in your calculator. It could give you a weird decimal. We don't really want weird decimals. We're just going to leave it like that. Okay, so no square roots in the denominator. On number 4, I know I'm all over the place here, but it says square root of 5 over square root over 2. Square root of 5 halves is the same thing as square root of 5 over square root of 2. Okay, which doesn't reduce, but you're not supposed to leave the square root of 2 on the bottom. So I'm going to do the same thing I did on 3. I'm going to multiply the top and bottom by square root of 2. Alright? So what's the bottom going to become? Some might say square root of 4, but that's just actually a normal 2, right? Square root times itself becomes a normal number. The top, since they are both square roots, you can actually multiply those together and simplify that. Square root of 5 times square root of 2 is square root of 2. So that would be number 4. Alright. Learning too much stuff, they're putting it on the evens. Number 9, there's a good one. Back to the odds. Square root of negative 20. Okay, as soon as I see the negative inside the square root, I'm thinking I. Okay, I is going to be part of my answer. But as far as square root of 20 goes, I'm going to do that like normal. Break it down. 20 is 4 times 5, and 4 is 2 times 2. So The doubles are gonna go in front. Double 2, that's gonna go in front, 5's gonna go in back. Okay, so it's 2 square root of 5. But remember there was supposed to be an I because of the negative in my answer. Well, where am I gonna put it? Well, where they usually put it is right in the middle there, after your rational number before the square root. Just like that. They don't like putting it back here because it looks like it might be under the square root, so that's not good. So I just put it right there. Alright, any questions? Great. Now let's go on to number 3. Or 11, I mean. Okay, square root of 48 fifths. Negative 48 fifths. Okay, I see a negative. That means I is going to be involved. We got all kinds of problems on this one. Okay, I'm going to start. So remember, this is square root of 48 over square root of 5. I'm going to start by simplifying square root of 48. 48 is 16 times 3, 2 times 24, either way. 16 is 4 times 4. I could break down the 4's again, but I'm not going to. Since they're already a double, I'm going to stop there. So this is going to be 4 square root of 3. Okay, 4 square root of 3. That's just for the top up here. The bottom is still square root of 5. And we can't leave square root of 5 on the bottom. So what I'm going to do, just like before, I'm going to multiply top and bottom by square root of 5. Okay, square root of 5 times square root of 5 is 5. We can go ahead and multiply the square roots together at the top. Square root of 3 times square root of 5 is square root of 15. Okay, that's almost the right answer. You guys know I did wrong. Kind of forgot about that negative right there for a while. So I should actually be part of my answer. So I'm going to put it up here. So I just slid I right in there. So now that is my answer. Square roots and normal numbers do not reduce. Can't divide them nicely. So we're going to leave it like that. Okay, 13 is different. It's an equation. We're not simplifying a square root right now. We're just solving an equation. Okay. If x squared is 169, so what this means is some number times itself is supposed to equal 169. Okay, so how do we solve that? Well, what times itself equals 169? What you're really asking is, what's the square root of 169? That's what square root means. Another way to think of this is, to get x by itself, I need to get rid of the square. What's the opposite of squaring something? It's square rooting. Okay, it's kind of like, what's the opposite of times 2 is divided by 2. The opposite of squaring something, taking something times itself, is square rooting. What times itself equals that thing. And if you square root one side, you should square root the other side. So on this left side, they just cancel out. You get x. On the right, we got square root of 169. Now, if you plug that in your calculator, it actually works out perfectly. Like, you don't have to do the tree on this one because it's a perfect square number. And the square root of 169 is 13. Here's the deal, though. Your calculator won't tell you this, but whenever you have something squared equals something else, 13 would not be the only thing that would actually work up here. If you think about it, 13 times 13 is 169, but what about negative 13 times negative 13? That would also be positive 169. So really we've got two answers, 13 and negative 13. Instead of writing it like this, which is okay, I'm going to write it like this. Positive or negative 13. Okay? Anytime you solve x squared equals something, you're basically going to have that kind of answer. Not only does the positive version work, the negative version works. When you plug a square root in your calculator, it only gives you the positive answer. But on these problems, x squared equals whatever, they could all be positive or negative. So we're going to see this on the next few problems. Okay, very similar problem. Z squared equals negative 27. So to get rid of the squared, I'm going to take the square root of both sides. So I'm going to get z equals the square root of negative 27. And really, I know this is going to come out as positive or negative already. Negative version is going to work too. So really, it's like number 5 here. We got to simplify square root of 27. That's the main point here. 27 does not have a perfect square root, so we're going to have to do the tree on this one. 27 is 9 times 3, and 9 is 3 times 3. The double goes in front, leftover goes in back, so it's going to be 3 square root of 3. There was a negative in there, so that means it's going to be 3i square root of 3. The plus or minus is just going to stick out in front, so I'm going to put up here. Plus or minus 3i square root of 3. The end of 15. All right. 17. Alright, this one says a squared plus 4 equals 0. So we want to make it look like the last couple of problems where it says a squared equals, and then we can take the square root of both sides. So I need to get rid of this plus 4, so I'm going to take away 4. And then if a squared is negative 4, that means a is the square root of negative 4. So I'm going to write that. I'm going to go ahead and put a plus minus square root of negative 4. Now we did the square root of negative 4 on number 5. You guys remember number 5? So square root of 4 is 2. So this would just be 2i. And don't forget the plus or minus. So it's plus or minus 2i. Okay. 19. All right, same idea. We want to get z squared by itself, and then we'll take the square root of both sides. So how can I get z squared by itself? Same as it getting like x by itself, really. So to get rid of this is like 24 plus negative 3 z squared. So to get rid of the 24, I have to take away 24. Negative 24 minus 24, negative 48. How do I get rid of the negative 3? Divide. Negative divided by negative is positive. Okay, z squared is 16. What do we do at this point? Square root both sides. What's the square root of 16? 4. Okay, don't forget it's still plus or minus. Z squared equals, it could be plus or minus. So on this problem, you could have done these on the last few problems, but if you get answer for z, you could go plug them back in and see if it actually works. Like if I plug in positive 4 there, you get 16 times 3 is 48. 24 minus 48 is negative 24. It works. If I plug in negative 4, it does the exact same thing, because negative 4 squared is still 16. All right. Anyway, that's 19. 21 negative 4y squared equals 20. Okay, so we're trying to get y by itself. So I gotta get rid of the negative 4. It's multiplied to y squared, so I'm going to divide it. 20 divided by negative 4 is negative 5. Take the square root of both sides. Remember, it can be positive or negative. Does square root of 5 simplify? No. Nothing goes into 5. There's no doubles inside of 5. So it's going to stay square root of 5. However, I cannot leave that negative inside the square root. I'm going to take it out as an I. So my final answer is plus or minus I square root of 5. Okay? So anytime you see that negative inside the square root, I is going to be part of your answer. Getting close. 7x squared minus 22 equals 4x squared plus 8. Alright, so I'm going to try to get x squared by itself again. I got x squareds on both sides. So just like when you have x's on both sides, you want to get rid of the x squareds on one side. So I'm going to subtract 4x squared. So 7 minus 4 is 3x squared. The exponents don't change when you're adding and subtracting. Okay, so just like a normal problem, you're going to add 22 divided by 3. I should probably mention, unlike Monday's assignment, on Monday's assignment we got everything to one side and factored it. None of these factor, okay? There's only an x squared term, there's not like a normal x term, okay? They're not factorable problems. If you can just get x squared by itself, there's no x's around, normal x's, then you can solve by getting x squared by itself. Alright, so I'm going to divide by 3. X squared equals 10. Take the square root of both sides. X is plus or minus square root of 10. The square root of 10 simplify. Well, 10 is 5 times 2. Those are both prime, so no. There's no doubles inside of 10, so it does not simplify. That would be the answer. Alright. Got one more? Oh, this mess. V minus 8 squared equals 24. There's actually a couple ways we could do this one. Oof. Let's I guess let's go ahead and take since the whole left side is squared, you can start by square rooting both sides. Because all of this is squared, you can get rid of that by square root. Here's the thing though. So on the left side, those just cancel out. So you get v minus 8. On the right side, we don't just have square root of 24, we actually have plus or minus square root of 24. Okay? To solve for v, I need to get rid of the 8. So here's what I'm going to do. those don't add together. First of all, this represents two different things, but you can't add an 8 with the square root of 20. They don't mix. So I'm going to write it like this: 8 plus or minus the square root of 24. Okay, those don't add nicely. Here's the thing though, square root of 24 does simplify because there is a double inside of it. So I'm going to simplify square root of 24. 24 is 4 times 6. Okay, so we have a double 2 and a leftover 6, basically 2 times 3, 6. So it's going to be 2 square root of 6. So this is 8 plus or minus 2 square root of 6. Okay, again, they don't add together nicely, so we're going to leave it like that. Yeah, this actually represents two different values. The first value is 8 plus 2 square root of 6. That's one answer. Second answer is 8 minus 2 square root of 6. That's two answers. So we could plug them both in the calculator and get a weird decimal. We're not going to do that. We're just going to leave it like this. But this does represent two numbers. All right. I want you guys to try the evens, and this will be due on Monday. Do your best. If you have questions on Monday after break, we'll look at it and see how well we did. I think for the Thursday, Friday assignment, I'll make it a review assignment and post that on RenWeb. All right, good luck. You can email me if you have any questions, that's fine.